Hello, let's do another problem. 981 time-based key value store. Design a time-based key value data structure that can store multiple values for the same key at different timestamps and retrieve the key's value at a certain timestamp. Oops. Implement the time map class. Time map initializes the object of the data structure. There's a function set that takes a key, a value, and a timestamp. It stores the key with the value at a given timestamp, and then get returns a value such that set was called previously with timestamp previous smaller than or equal to timestamp. If there are multiple values, it returns the value associated with the largest timestamp prev. If there are no values, it returns empty string. Okay, so let's think through the structure of what they want us to keep. Right, so we're going to get, there's going to be a function called set, and function set, we're going to get a key, a value, oops, not a wall, a value, and a timestamp, right? And they want us to save this in some way where it's keyed and there's multiple values, right? So I'll call this v1, v2, v3, and they want this to be stored at some given timestamp. So in the future, when they call something like get, they're going to call get with a key and then some type of max timestamp, right? So maximum time, right? So if these timestamps are associated with the values, so let's say this is T1, this is T2, and this is T3, these are going to be input, hopefully if the timestamps are consistent, where these orderings matter, right? So T1 is going to be smaller than T2, which is going to be smaller than T3, right? So I think we have that guarantee. Okay, so we want to get the key for that given, the key, and then the element here. I'm going to move get out of the way. The element here that has the timestamp that is smaller than this maximum timestamp, right? So let's say the max timestamp, for example, was T1.5. Then we want to go over here, look, and be able to return T1, right? Let's say the T was 2, right? So max equals T2. We want to be able to return the value associated with T2. And let's say, I'm going to move this out of the way. The maximum is something like T, T0, right? So T0 is going to be back here. It's going to be nothing larger than it. They want us to return an empty string in that case, right? So inside of our structure, however we want to store it, we need to be able to store this time associated with it, right? We can store the value there as well, let's say as tuples. So I drew some stuff in advance for this problem, which is different. So let's look at what we have here. So our time-based key value store will look something like this, right? We'll have some key, and then in there we'll have a list, and that's going to be in order of time, and there's going to be some value associated with it. Here I only wrote the times, but you can imagine it's a tuple with time and value. Now, here's some examples of what we can get. Let's say for get, if they wanted it at key 8 and 2005, well, just like we went through before, 2005 is not represented, return none. 2009, 2008 is the maximum one that is smaller than or equal to 2009, so we'll return 2008. 2030, if you don't know what I'm talking about, this one right here. Well, 2030 is larger than all of them, so we can go ahead and return 2020 for that one, right? Okay, so we can do a linear search, right? But this list can get very long. Because we know that the timestamps are sorted, it's always going to be in a sorted format, we can actually do a binary search, right? So here's an example, right? On this timeline, imagine these are all of the values inside one of these arrays, right? So let's say when this accumulates enough information, it becomes this timeline. Well, when that happens, we can actually just do a binary search, right? So let's say we're searching for max year 1999. Well, binary search, we can start a left and a right. Our midpoint is going to be 1980. Is 1980 the largest value that we can possibly return? It's not, but it's actually the largest value that we've seen so far. So we can go ahead and record that, right? The largest value that we've seen so far, 1980. Now, because 1980 is smaller than our max year, we can go and make sure that our binary search goes to the right, right? We're going to the right side. Now we have to recalculate a mid. If we recalculate a mid is going to be right here. It's going to be the year 2000. 2000, a little bit larger than 1999, so we're going to do binary search again, and this time we're going to move to the left, right? We're going to move to the left. We're going to be over here, same indice. 1990, is that smaller than 1999? Yes. Right, so let's scratch that. The largest value is 1990, and this is what we're going to want to return. Right, so this is, exactly the code that we're going to want to write here. I'm going to put that to the side like we usually do, and let's write some code. I'm going to move this so we can see it. Right, so what type of data structure could we use here? We can use a dictionary, and that dictionary is going to have keys. The keys are going to be keyed to a list, right? So I'll just call that state here. And that's a dictionary. And I'll just leave a comment where it's going to be some key, and it's going to be a list where what's inside of that list is going to be some time and a value, right? And it's going to be a list of those. Okay, so what does it mean to set? We can actually use a default dict here and default that to a list. What does it mean to set? It means that for self.state, at this key, we're going to append both the timestamp and this value, right? And what does it mean to get? To get, it means that, for this key, there's some options of the timestamps and the values that we have available. I'm just going to call that options, and that's going to be self.state at this key, right? So in this diagram, it's going to be this golden array right here. We're going to get that golden array out, and then we're going to treat it as a single sorted array that we can do a binary search on. Right? How do we do a binary search? We have a left pointer and a right pointer. I'm going to set that to the length of options for the right pointer -1, because that's going to be the last index. And then while left is equal to right, while left is smaller than or equal to right, we're going to do some comparison and figure out if we should move left or right. Okay, so when do we move left and when do we move right? Well, what is the value that allows us to compare, right? So we have a max year. A max year is on line 12, it says timestamp. It's actually max timestamp, right? And I think for clarity, yeah, just keep that in your mind. Timestamp actually means max timestamp. If you want, you can also make a, something like this to make it less confusing, but that's max timestamp. Okay. So what's mid? So mid equals left plus right, dividing with the floor here, and then the mid value is what? Well, for this single element, we're going to have a timestamp, and we're going to have a value, and that's going to be options at mid, right? Okay, so if this element is, let me move my diagram back just so we can all look at the binary search again. This will be 0, 1, 2, 3, 4, 5. 5 divided by 2 is going to be 0, 1, 2. Okay, so imagine here in this left, mid, right scenario, right, our timestamp is going to be 1980, right? So if 1980 is smaller than, or let's say this, if the max timestamp is larger than this timestamp right here, right, then we want to move right. And we also want to save it, right? So we have this largest value seen, basically, and that's going to be none. We're going to start off as none. Or I guess it can start off as that empty string, the one that they want us to do in the null case. Delete this so it's easier to type. Largest val. Okay, so the largest val will be this value that we just have right here, right? And then we want to move right. And moving right means that the left is now equal to mid plus 1. Okay, so that's going to the right. And then what does it mean to go to the left? It means that the right is mid minus 1. Right. So let's think about the different cases that we have here just to make sure. Let's say our max year was not 1999, it was actually 1980, right? Which is the same value as this mid. And in binary search, usually we're searching for an exact value, right? What happens in our code if this happens right here? Well, we're not setting it. We're not setting it. So we need a greater than or equal to here, where if it is equal, we go ahead and I mean, if it's equal, we can actually just break, right? So we can go ahead and say, let's explicitly do it. Max. Well, can you have two things of the same timestamp? No, I don't think so. So if max timestamp equals L timestamp, let's be very explicit about it. And the largest val is updated. Else, if it's larger, then not only is it updated, but we're going to move right. Else, we're going to move left, right? And actually, for this update, we can go ahead and break. So we handled the cases, the equal, max timestamp being larger, and then max timestamp being smaller. Let's test this, make sure our code syntax is correct. Great, syntax works. Awesome, we pass all tests. Great. So the key idea here, I believe, is timestamp has been stored, and we're just supposed to infer that these are now sorted. That the timestamp is sorted. We have a sorted array, and for speed, we can do binary search on any sorted array, looking for a specific target, right? And yeah, that's the insight. All right, thanks everyone. Hopefully this diagram and this code makes sense to you. I wonder if I can put them side by side. And wish I could code into my diagram because I feel like you'd be able to see everything correctly. But you can see that the set is setting it into this data structure right here, and the get is performing this binary search, right? And we've done the different operations where if it's equal to, like here it's equal to at 1980, then go ahead and break. If it's larger than, like if it's this 1999, then we're going to, progressively move right until it doesn't make sense anymore. And, once you're familiar with binary search, you can pull this out in any problem where you now have a sorted array, you have a target, and you can quickly move through. Thank you so much. See you in the next problem.